Okay. Okay, ma'am. So let me just rewrite that thing. 45x by 4 minus 2x is equal to 25 by 8 minus, what was the last thing? 2 by 3.
2 by 3.
Okay. Now, Hiba, can we take over here, if you see, can we take x as common?
Yes.
Okay. So then we'll be left with this 45 by 4 minus 2. Okay. And then you take x as common outside the bracket is equal to this thing, 25 by 8 minus 2 by 3.
Why do we have to remove the x?
We're not removing the x. We are taking it common outside the bracket so that we can solve this fraction. We have to subtract two fractions, right? Like just like over here, we can solve it just like that. We're gonna solve them.
Okay.
Okay. So now you can write this as divided by 1, 2 by 1. Yeah. Hiba.
Yes.
Let's take the denominator. Sorry, let's take the LCM of the denominators on the left hand side. What is it? What is the LCM of 4 and 1? Yes, it is 4. So can you tell me
40,
what? Yes.
3 by 4.
No. Hiba, 1 multiplied by what is 4?
4.
4, right? So you have to multiply 2 with 4 because see, you have to make this 2 by 1 into a fraction whose denominator is 4, right? Because here the denominator we saw that the LCM is 4. We need to take the denominator as 4. So 1 multiplied by 4, 2 multiplied by 4. So 45. So this 2 4s are 8, right? So 45 minus 8 by 4. Did you understand this, Hiba?
Yes, and
Then our x as it is, then is
wait,
equal to,
we have to. How can we? Nothing.
are you sure? Clear?
Yes. Can you? How did you get -8?
Okay. Hiba, see, we have 45 by 4 minus 2 by 1. So we need to see, we can't just subtract them like this, right? Because they are not like fractions. Like you can say 3 by 5 minus 2 by 5. Why? Because you can easily say that it is 1 by 5. Why? Because the denominators are the same. I'm sorry. But you can't say the same thing about two fractions where the denominators are not the same. For example, 3 by 8 minus 5 by 9. You can't subtract them now because the denominators are different. So in this case, what do? We take LCM, right?
Yeah.
So the same thing we are doing here. We are taking LCM. So LCM of 4 and 1 is what?
4.
4. So now we need to make sure that both of the fractions are in such a way that their denominator is 4. So the first fraction is obviously going to be 45 by 4. It's going to be as it is. The second fraction, however, 2 by 1, you need to make it in such a way that the denominator is 4. So what do? You have to multiply this thing by 4. So you automatically you will multiply the 2 also with 4 only. So 2 4s, right? That's how you get -8, because this is -2. So here we put -8 by 4.
So it will be 37 by 4x gives 25 by 8 minus 2 by 3.
Wait, 37. We will just calculate this later. First, let's do the same exercise to this part. 8 and 3 denominator, LCM.
Can you say it again?
LCM of the denominators 8 and 3.
Do we have to find it right now, or like do we have to first find the answer for?
No, it's okay. Find it right now. Because it is better to do the same thing simultaneously, no? Otherwise, you will keep on writing the same thing again and again. First, you will solve this, then you will solve that. So I think it's better to just solve it simultaneously. It will make it quicker. Do it on another in another rough column or something.
Okay.
Hiba, first of all, 8 and 3, are they co-prime numbers? First of all, they're not primes, but yeah, are they co-prime? What does co-prime mean? That both of them, they don't have any factors in common. So are 8 and 3 co-prime?
No.
What factor do they have in common?
2 and 4.
2 is a factor of 3. Hiba, see, when we are taking LCM of two things and two numbers, for example, if you are taking LCM of, let's say, 4 and 5, just quickly find out the LCM of 4 and 5.
$20.
20. Now find out the LCM of 4 and 6.
2, 4, 3, 2, 1, 3, and 3, 1, 1. So it will
What
be
is the LCM?
12.
Hiba, 4 and 5, do they have any common factors? What are factors? You know factors, right?
Yeah.
What are the factors of 4? 1, 2, and 4. Okay, so right now we are not talking about 1 and the number itself. We are only talking about other factors. So what are the factors of 4? Only 2. The factors of 5, there are no factors of 5 other than 1 and 5 itself. So the question here is, are there any common factors between 4 and 5?
2.
2 is a factor of 5. Is 2 a factor of 5, Hiba?
No.
No, right? So can you
There,
please list?
there are no common factors.
Yeah, right. There are no common factors between 4 and 5. So those two numbers which don't have any common factors other than 1. Okay, because 1 is obviously a factor of every number, so we don't count it. Okay, we don't mention it. So those two numbers which don't have any common factor, they are called co-prime numbers. Those numbers don't necessarily have to be prime numbers in and of themselves, but if they both comparatively, they don't have any common factors, then they're called co-prime numbers. Fine. So over here, 4 and 5 are co-prime numbers. The thing about co-prime numbers is that if you want to find their LCM, you don't have to sit and do this whole thing. You can just multiply those two numbers and you will get the LCM. Got
Okay.
it?
Yeah.
But if the two numbers are not co-prime, what does that mean? It means that they
They have a
do
common
have some
factor.
common factors. Exactly. Just like 4. What are the factors of 4? 2, right? What are the factors of 6? 2 and 3.
3.
So they do have a common factor. So that is why the LCM will not be 4 multiplied by 6, which is 24. No, the LCM is not 24. Getting it?
Yeah. How do we find if a number is another number's factor while finding the LCM?
That how do we know if one number is a factor of another number? Divisibility rule. Or if you just look at this, okay, if I give you some big numbers, like let's say 36 and 48, then you instantly know that they have, I'm going to write factors over here, okay, factors of 36 and 48. Then you instantly know that 2 is a factor of both of them. Why? Because this is an even number. This is also an even number. Heba, are you forgetting the divisibility rules? Last year you
No.
must have studied. What happened? You remember?
Yeah, if we talk about it, then I remember.
Okay. So 2 is a factor of both of them. What is the divisibility rule for 3? How do you know if a number is divisible by 3 or not? How do you know if 3 is a factor of the number?
If a number is divisible to 6, then it is divisible to 3.
No. The divisibility rule of 3 is that when you add all of the digits of that number, you should get a number which is divisible by 3. Or you should get a number which lies in the table of 3. So when you do 3 plus 6, 3 plus 6, 36, right? 3 plus 6 gives you what?
9.
9. 9 is in the table of 3 or not?
It is.
It is. So 3 is a factor of 36. What about this number? Do 4 plus 8.
It is also a factor.
Yes, 3 is a factor of 48 also. Let's see
Yes.
4. Okay. In 4, basically, if you have a bigger number, like let's say 124 or something, then you see the last 2 digits. If the last 2 digits are divisible by 4, then the whole number will be divisible by 4. Okay.
Okay.
It doesn't matter what the other digits are. Other digits could be anything. If the last 2 digits are divisible, then the entire number will be divisible. So in these two numbers, we don't really have anything apart from the last 2 digits. So yeah, just read out the table of 4. 4 nines are 36, right? So 4 is a factor of 36. 4 12s are 48. If you see 48 divided by 4, 4 ones are 4 and 4 twos are 8. So 4 12s are 36. 4 12s are 48, right? Hiba, you following me?
Yes.
Okay. So 4 is a factor of this also. Now 5.
5. If the last number is 0, it is divisible by 5.
Last number is 0 or 5.
Oh yeah, 0 or 5. It is divisible by 5.
So these two are not divisible by 5. Okay. Then what about 6?
If a number is divisible by 3, then it is divisible by
No.
6.
Acha, how about the number this thing 15? 15 is divisible by 3, right? Is it divisible by 6?
No.
No. So what you said turns out to be wrong. In fact, the thing you're getting a little bit confused. If a number is divisible by both 2 and 3, then it is divisible by 6. Okay. So it's like if a number is divisible only by 3 but not by 2, then it is not divisible by 6. If a number is divisible only by 2 and not by 3, then also it's not divisible by 6. In order for it to be divisible by 6, it has to be divisible by both 2 and 3. Clear?
Yes.
So here we can see it's
So it is
divisible by
not.
both 2 and 3.
So it is divisible by
6.
6.
Yeah. Because 6 6 are 36 and 6 how much are 48? 6 8 are 48, right? So 6 is a factor of both of them. How about 7? I gave a very lame number. I shouldn't have given 48. I should have given some other number. Um, maybe 30 or something, but okay, fine. Huh. 7? There's no divisibility rule for 7. You have to check, okay? You have to like properly divide and check. So over here, it's not divisible by 7. What about 8?
I think if a number is divisible by 4, then it is divisible by 8.
Okay. What about 28? Is it divisible by 4?
Yes.
Yes, it is divisible by 4. 4 7 28. Is it divisible by 8 though?
No.
No. So what happened to your hypothesis? Not true, right?
Yeah. Yeah.
So the divisibility rule for 8 is that if it's a big number, let's say 1 0 2 4 or something, then the last 3 digits have to be divisible by 8. If the last 3 digits are divisible, then the entire number will be divisible. So in the case of such small numbers, you just have to divide and check. So you can see that 36 does not divide 8, right? Because you have 8 5 8 6 8 fours are 32. In fact, you have 8 threes are 24, 8 fours are 32. So you don't, and then the next thing you have 8 fives are 40. You don't have anything between 32 and 40. Fine. So 8 is
Okay.
not a factor of 36, but 8 6 are 48. So you have 8 is a factor of 48. Okay.
Okay. For 9, if the number is divisible by 3, then it is divisible by 9.
What about the number 15 again? It is divisible by 3? Yes.
Yes.
Is it divisible by 9?
No.
No. See, Hiba, your a little bit of your concept is fine. A little bit is you're confused in a little thing. So the thing is, Hiba, you can say that if, see, you have the numbers like 9 6 8. So if a number is divisible by the bigger number 9, then it will definitely be divisible by the smaller number 3. Or if a number, because 3 is a factor of 9. Okay, if a number is divisible by the bigger number 6, then it will be divisible by its factors, all of its factors, like 2 and 3. It will be divisible by 2 also and by 3 also. Okay, you cannot say the other way around, that if a number is divisible by the smaller number, then it will be divisible by the bigger number. No, if it is divisible by the bigger number, then it will be divisible by all of its factors. So you can say that yes, if a number is divisible by 8, then definitely it will be divisible by 4. But you cannot say the other way around. You cannot say that if a number is divisible by 4, then it will be divisible by 8. Are you understanding? Hiba?
Yes, I understood.
Okay. So then there's a few other factors also. I'm not going to write them all here. 6 36, 4 9s are. Wait.
How do we know if it is divisible by 9?
Okay. So the divisibility rule for 9 is that you add all of the digits and they should be a number just like 3. What are you doing in 3? In 3, the rule is you have to add all the digits. So in 9 also, the rule is add all the digits. But in 9, the difference is the sum of all the digits should be a multiple of 9. In 3, what was the rule? The sum of all the digits should be multiple of 3. Here, the sum of all the digits should be multiple of 9.
9.
Got it?
Yes.
So as you can see, 3 plus 6 gives you 9. But 4 plus 8 gives you 12. And 12 mein 1 plus 2 does not give you, it gives you 3, right? But 3 is not, it's not in the table of 9. You read the table of 9, you don't get 3 over there. So yeah, or you can say you read the table of 9, you don't get 12 over there. Fine.
Okay, understand.
So 9 is not a factor of 48. So the next thing we come across is 10. For 10, the rule is the last digit should be 0. Okay, that's very obvious. So 10 is not a factor of either of them. Now, one more thing you can say is if 2 and 5, both of them are factors of this number, or any number, then 10 will also be a factor. But since 5 is not a factor, so 10 is also not a factor. If 2 and 5 both are a factor, okay, not just 2, not just 5, both of them together. Are you getting it?
Yes.
Just like we had with 6. Anyway, so the next thing now we have is so 9, and then you check for 3 12s are 36, and then 18 2s are 36. Here we have 8 6 are 4 12s are 3 16s are 48, and 2 24s are 48. Okay. um okay, so these, we were just talking about factors. Anyway, let's come back to this. So I was saying that so this is the thing about co-prime numbers. Now let's quickly come to this. 8 and 3, they are co-prime numbers or not? Look, what are the factors of 8? Or you can say it like this: if you have 8 divided by 3 somewhere, let's just imagine you have 8 by 3. Can you cancel any of them? No, right?
No.
So that means, why can't you cancel? Because they don't have any factors in common.
So it is not
So
divisible.
they don't have
They
any
are not
factors in common. So they are co-prime numbers. So if they are co-prime numbers, what you can do is just multiply them. If you want to find the LCM of co-prime numbers, you just multiply them. So we multiply 8 and 3, we get,
What if we are finding the LCM?
yeah. Hello. Yes,
Can
Siva?
you hear me?
Hmm. I can hear you.
We get 24.
Yeah. Now tell me, what do we do? So in order to make this whole fraction in such a way that the denominator is 24, what do? We multiply both the denominator and 24 by the same number. By which number should we multiply both the denominator and numerator? 8 multiplied by what will give you 24?
3.
3,
Sorry,
right? So in
yeah,
this,
3.
yeah, 8 3s are 24. So 25 3s are
75.
Then the next thing, oops. Then the next fraction. 3 multiplied by what will give you 24?
Multiplied by 8. So
8.
it will be
So 8,
16.
2 multiplied by 8. 75 minus 16 is how much?
Um, 58. No, 59.
So till here, is it clear?
Yes.
Have you written it down?
Yes.
Okay. Now what do we do here? Let me just select all of this and send it a little up. Okay. See, Hiba, Now this we can send this 37 by 4, the entire fraction, to the right hand side, because what do we want on the left hand side? We want only x. Okay. So this 37 by 4 is being what with x?
Multiplied.
Multiplied, right? So what will we look at? We want its multiplicative inverse. So when it goes to the other side, what will it become? Multiplicative inverse of 37 by 4 is
4 by 37.
very good. So 59 by 24 will be as it is, multiplied by 4 by 37. Okay.
Can you give me 1 minute?
Okay.
Why did you multiply 4? Why did you multiply 4 and 37?
No, I'm not multiplying 4 and 37. It's 4 by 37. 4 by 37
4
is
by
one
37.
fraction. What's your
Why
question?
are you multiplying it?
Because over here 37 by 4 is being, what is the, fill in this block, this
Multiply.
box, multiplied. So we will multiply.
Okay. So it will be 2183.
Okay, Hiba, just a minute before you go into that. Just can you see if we can cross out this 4 and 24 somehow? 4 6 are Hiba, 4 6 are how much?
24.
24, right? So we have 59 by 6 multiplied by 37. Okay, because 6 and 37 are both multiplied and they are in the denominator. So 59 by 6 multiplied by 37. You can keep solving it by yourself, but this is how we solve an equation. You understood, Hiba?
Yes.
Okay, so now you know how we can solve anything using transposition method.
Yes.
Okay. So all right. So in the next class, Hiba, let me tell you what we're gonna do in the next class. Today is what date? 12. No, it's 11. So Hiba, in the next class, we will revise fractions and decimals. Okay.
Okay.
I'll give you a few questions from here and there. And apart from that, you will have a test from the integers chapter and fractions and decimals. Okay. So your homework is to revise integers, fractions and decimals. And fractions and decimals may say I will give you, I'm sorry, just come up with any doubts that you have. Okay. Because then tomorrow you will have a test from both of these chapters, integers and fractions and decimals. Okay.
Okay.
Okay, fine. Thank you. Bye bye.
Tomorrow?
Yes, tomorrow. Tomorrow is what? Wednesday, right?
Yeah.
Okay. Let me just check the timing. Yeah, so tomorrow we have a class from 7 to 8.
I
I'm
will try
sorry,
to
that's
complete
Indian time,
both.
7 to 8.
I will
What?
try to complete. I will try to complete both chapters because we also have revision at school.
Revision of math.
Yeah, of other subjects also.
Okay, so you have to study for them.
Yeah, I will try to
See,
complete it in
Hiba,
practice.
do this. Don't. It won't be possible for you to just study the entire chapter and practice the whole two chapters and all the exercises. So just take a rough look at the exercises. Okay, both the chapters. Take a look at their exercises, and if you come across something, just read the exercises. Don't solve them. Take a look at them, and if you think some question looks difficult, try solving it. If a question looks like a little difficult for you, that you won't be you're having some doubts about the question, try to solve it. If you're not able to solve it, note it down somewhere. Okay, we will